Hello students, today myself, Professor Bansri Thakkar, Computer Engineering Department from AIT College. Today I am going to explain you the topic of computer organization architecture. The topic name is Input-Output Organization with Handshaking Method. What is input output devices? The introduction given here is the peripheral devices are the input or output organization of computer that depends upon the size of a computer and the peripherals connected to it. The IO subsystem of the computer provides an efficient mode of communication between the central system and the outside environment. The most common input-output devices are monitor, keyboard, mouse, printer, and magnetic tapes. Now, the devices that are under the direct control of the computer are said to be connected online. Input-output interface provides a method for transferring information between internal storage and an external I/O devices. The peripherals that are connected to a computer, and they also need a special communication links for interfacing them with the central processing unit. So, the purpose of communication link is to resolve the differences that exist between the central computer and the each peripheral. Now, the computer with I/O processor. This block diagram of computer with its own I/O processor is shown here. The central processing unit, that is CPU, and the input-output processor. Both are connected with the memory unit using memory bus. Now, memory unit is connected to CPU and IO processor in a two-way direction. So, at the same time, one can transfer the data in both the directions. So, reading and writing, both the operation of data transfer could be done in a single way. And input-output processor is connected with each and every peripheral devices. That means the input and output devices are connected with the input-output processor. The input-output processor simply controls the activities or data transmission of peripheral devices using I/O bus. Now, peripheral devices are shown here using PD, that peripheral devices. Each peripheral devices is connected to its processor using I/O bus. Data transfer between peripheral devices and data transfer between one peripheral devices with the input-output processor is done using I/O bus. Now, there are number of modes of data transfers. Here, we are going to understand the asynchronous data transfer. What is the asynchronous data transfer? Now, this scheme is used when the speed of I/O devices do not match with the microprocessor and timing characteristics of I/O devices is not predictable. In this method of data transfer, the process initiates the device and checks its status. As a result, CPU has to wait till I/O device is ready to transfer the data. Now, when the device is ready to transfer the data, the CPU issues an instruction for input and output transfer. In this method, two types of techniques are used based on signals before the data transfer. The two types of techniques are, one is strobe control and the second one is handshaking. Now, what is the strobe signal? The strobe means, or the strobe control method of asynchronous data transfer employs a single control line to time each transfer. The strobe may be activated by either the source or the destination unit in a data transfer from source to the destination, or in a reverse direction from destination to the source unit. Data transfer is initiated by the source unit in this case. Now, the block diagrams shows the two ways of data transfer. Once the source unit transfers the data to the destination unit, and the second one is the destination unit transfers the data to the source unit. That is the exactly reverse of the first block diagram. Now here, the data and strobe both are shown in a timing diagram, and source unit and destination unit are shown in a block diagram. In a first diagram, the source initiated strobe for the data transfer is shown, where the valid data and the strobe both are transferred from the source unit to the destination unit using the data bus for data transmission. In the second block diagram, the destination initiated asynchronous data transfer is shown, where the destination unit transfers the data to the source unit using the data bus in a asynchronous mode of data transfer. Now, in the block diagram figure A, the data bus carries the binary information from the source unit to the destination unit. Typically, the bus has multiple lines to transfer an entire byte or one word. The strobe is simply a single line that informs the destination unit when a valid data word is available for the data transmission. The timing diagram of figure B, the source unit first places the data on the data bus, the information on the data bus and the strobe signal remain in the active state to allow the destination unit to receive the data. Here, the data transfer is initiated by the destination unit. In this method, the destination unit activates the strobe pulse to informing the source to provide the data. The source will respond by placing the requested binary information on the data bus. The data must be valid and it should remain in the bus long enough for the destination unit to accept it. When accepted, the destination unit then disables the strobe and the source unit removes the data from the bus. Where is the disadvantage of strobe signal? The first disadvantage of the strobe method is that the source unit, which is initiating the transfer of data with the strobe, has no way of knowing whether the destination unit has actually received the data item that was placed in the bus. Similarly, the second advantage shows the reverse of the same. When the destination unit that initiates the transfer, it also has no way of knowing whether the source unit has actually placed the data on the bus. Now, the handshaking method resolves the problem of strobe method for data transfer using asynchronous mode of data transfer. What is the handshaking method? Now, the handshaking method solves the problem of strobe method by introducing a second control signal with the first one, the strobe signal, that provides a reply to the unit that initiates the transfer. So here you can know the data is accepted by the destination register or not. Now, what is the principle of handshaking? The basic principle of the two-wire handshaking method of data transfer is as follows. One control line is in the same direction as the data flows in the bus from the source to the destination. It is used by source unit to inform the destination unit whether there a valid data in the bus is present or not. The other control line is in the other direction from the destination to the source. It is used by the destination unit to inform the source unit whether it can accept the data or not. The sequence of control during the data transfer depends on the unit that initiated the transfer. Now, the source unit initiated the transfer using handshaking is explained as follows. The sequence of events shows four possible states that the system can be at any given time. The source unit initiates the transfer by placing the data on the bus and enabling its data valid signal. The data accepted signal is activated by the destination unit after it accepts the data from the bus. The source unit then disables its data, it accepted the signal, and the system goes into its initial state. Destination initiated transfer using handshaking. The name of the signal generated by the destination unit has been changed to ready the data to reflect its new meaning. The source unit in this case does not place the data on the bus until after it receives the ready for the data signal from the destination unit. From there on, the handshaking procedure follows the same pattern as in the source initiated case. The only difference between the source initiated and the destination initiated transfer is in their choice of initial state. Here the block diagram of handshaking is shown where the source unit and destination unit transfers the data using data bus with the two signals. One is data valid, the data valid data to be transferred via initial state to the final state, whether it can be source unit or the destination unit as the initial state. And the second signal is the data accepted signal, which solves the problem of straw method in the handshaking method. Now, the advantage of the handshaking method is the handshaking method or the handshaking scheme provides degree of flexibility and reliability because the successful completion of the data transfer relies on active participation by both the units. If any of the unit or if any one of unit is faulty, the data transfer will not be completed. Such an error can be detected by means of timeout mechanism, which provides an alarm if the data is not completed within the time. Now, the data transfer can be handled by various more methods, that is programmed IO, interrupt initiated IO, and direct memory access. Now students, we will understand this basic three methods of data transfer in a next video lecture. Thank you.